So a couple of review problems from section 9.2. First of all, do you remember the little trick that I gave you guys to help convert something with rational exponents to something with, radicals? The boot method, yeah, all right, well done. So you're going to imagine a boot here next to the denominator. It's going to kick the denominator, so the 4 comes over and the 3 drops down like that. So great. Now you can kind of start telling that there's going to be a problem underneath here. And the reason for that is because you're going to end up with a negative number underneath the radical. So if you were to actually cube this out, you'd get the 4th root of 531,441. But it'd be negative. And there's a problem there, right? You can't take the even root of a negative number. Odd root, you're okay. But even root, no real number. Now kind of keep an eye on that, because later on in the semester we will have something we can do there. I'm just saying that now it's not a real number. There is something we can do on that. Isn't this just kind of the same down here? You know, aren't these two problems more or less the same? Should I get the same answer with that one? There's a subtle difference between these two problems. So there's the first one. But for the second one, this only applies to the base. So yeah, okay. Thank you. So when I rewrite this, it's going to be the negative on the outside, the 4th root of 81 to the 3rd power. And personally, when I do these things, they're always geared so that they work out pretty nice. I start out with the radical part first. What do you raise to the 4th power to get 81? Well, 2 to the 4th power is 16, so the next one up would be 3. 3 to the 4th power is 81, so perfect. So let's see, we've got the negative still out in front. 4th root of that is 81, or 4th root of 81 is 3, but I've also got that to the 3rd power, so I end up with negative 27. Now you should be able to get that off your calculator as well. In fact, I want to practice the calculator for a couple problems coming up, but let's take a look at it with this one. Just make sure we get the same thing. So I want negative 81 raised to the 3/4 power. 3 divided by 4. Bam. Now what if I had parentheses around that? Is my calculator going to tell me, oh, there's a problem? It should. Unless you're set up to do complex numbers. Yeah, so it's an error. It's telling you kind of the same thing I did. It says there's no real answer. Okay. Now technically, if you've listened to enough commercials that say offer voided, prohibited, family and friends excluded, blah, 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 all these disclaimers, that's kind of a disclaimer. It's not saying that there's no answer altogether, it's just saying there's no real answer. So we'll have to figure out what that means in chapter, let's see, yeah, I think at the end of this chapter. All right, so how about this one? Well, you've got a negative exponent here. You can get rid of the negative exponent by moving that whole term into the denominator like this. And now you can focus just on the denominator part. How would you rewrite this with radicals? Can anyone do that for me? How would this look if I was to write 1024 to the 7/5 power with radicals? Someone got my back on that one. Yeah.
It would be the 5th root of 1024 to the 7th.
Perfect. 5th root of 1024 to the 7th. Nice. Nice. So let's see if we can't make a little more progress here. The 5th root of that, well, maybe you want to take out your calculator for doing it. In fact, you could take your calculator out and do the whole thing from here or even here. I think the fifth root of that's going to be 4, so it's going to be 1 over 4 to the 7th power. Let me think here, let me think. That's going to be 1 over 16,000 and something. Let's see, 16,000, 48, 96, 16,192? Let me take a guess, let's see.
16,384.
384? That's 16,384. 192 is exactly half of that. I was off by a factor of 2.
So close.
Yeah, so close, so close. Now, you can do this, like I said, you can do this on your graphing calculator. And one of the things I'm going to be expecting from you on the exam is to do just that. I'm going to give you a problem. In fact, let's take a look at the next one. Let's see, I'll do them both at the same time, this one and the last one. But if you take a look at the next one, that's just a mess. There's a lot going on here. And what I'd ask you to do is just give me a fraction. Now you can do a little bit of work here to make your life easier. If you wanted, because there's a negative here and you've got a fraction, you can make that a positive by taking its reciprocal. So now the positive 2/3. And then you can rewrite that with radicals. The cube root of 343 over 125 squared. And as I said in my videos, do the radical part first. Cube root of 343, well, you know, that's 7. What's the cube root of 125? You guys should be used to that one by now. 5. And then I got the whole thing squared. Now, what do you get when you square 7? What do you get when you square 5? 49 over 25. Let's see if we can't make that work on our graphing calculator. So let me clear out all this old stuff. You can follow along my keystrokes here. So parentheses, 125 divided by 343, close parenthesis, raised to the negative 2/3 power. So exponent negative 2 divided by 3. Now you're going to get a decimal answer. I don't want decimal answers. On the test, I'll specifically say I want a fraction. So go to the math key, press answer to fraction, and bam, it's exactly what we just got. Perfect. All right. Now, do you have to do all the stuff in between? No. I'm going to give you a problem that says, just give me a fraction here. If you get it off your calculator, hey, I'm fine with that. If you do it the long way, even better. Should we go back and do this one with our calculator too? Yeah, why not? So 1,024 to the negative 7/5 power. Let's do that one. So clear out this old stuff. 1024 raised to the negative. And make sure you use the opposite key on the bottom of the calculator, not the subtraction key to enter your negative numbers. So pretty small, but I'm hoping, might not be able to get away with the math, the fraction stuff. No, so it's too small so it doesn't quite recognize it. I guess the workaround is maybe we can do 1024 raised to the 7/5 power, and then realize that that term has to be in the denominator. There you go. So there's your 16,384, but that would be in the denominator. So a little bit of workaround for you. It's not always going to recognize your answer to fraction stuff. 2 more, each with kind of a little special thing here. I could ask for you to work these things in an opposite direction. Start out with something with radicals and write it with rational exponents. Now this one I chose kind of carefully because it looks so tempting to just say, oh, well, the cube root of that is going to be x squared plus the cube root of that is going to be y squared. Done. Unfortunately, it doesn't work that way. what you've got to realize is that these two terms here are kind of stuck together. They're married. You can't take the cube root of one plus the cube root of the other. Instead, this is something to the first power like that. So we'll use the old football play, right? The reverse boot. The 1 comes up, 3 comes over. I'm left with x to the 6 plus y to the 6 raised to the 1/3 power. And that's it. There's your answer. One, maybe two more.
Would we leave it like that?
That's all you can do.
By it.
That's I know it's screaming out like, oh, you should, multiply the 6 by 1/3 and multiply the 6. It's not equal to x to the second plus y to the second. If you were to cube this, you wouldn't get anything close to this. It'd be a big mess, but you wouldn't get anything close to it. So, as kind of an example that you can't take the square roots like this and just add them up, let me give you this example with square roots. So square root of 25 plus 144. It looks really tempting to say, oh, well, that's the square root of 25 plus the square root of 144, which would be 5 plus 12 is 17. Does that work? Well, this is the square root of 169, which is 13, and no, that's not 17. So there's a nice numerical example that it just doesn't work. I mean, I wish it did. A lot more people would get A's on their math test, but unfortunately it doesn't. So let's look back at this one. There's an important reminder here. I can rewrite this as the 6th root of 64x to the 6th raised to the first power. I really don't need that raised to the first power, so it's just the 6th root of 64x to the 6th. I'm going to split this up as the 6th root of 64 and the 6th root of x to the 6th. This is a number you can get off your calculator. Maybe you should practice that. Try and find the 6th root of 64 on your calculator. Make sure that you can get that. I see a couple people digging for it. The rest of you, do you even know where to find that 6th root key?
Math.
Yeah.
The math.
Math key, good. So the math key, and then you want the 5th option down, assuming you're using a TI-84. And then I want to put in a 6 here, and in my 64 here, you should get 2. Great. So that first part's 2. How about the second part? What do I get for the second part? Second part's worth 2 or 3 points. So get it right. No one?
Absolute value.
Ah, well done. Absolute value of x. Why is it the absolute value? How come I need the absolute value here? If I did the 5th root of x to the 5th, I wouldn't need the absolute value here. So why do I need it here? Ah, because it's even. If these things match and they're even, that's when you need the absolute value. Here they match, but it's odd, so you don't need the absolute value. There's a big difference in those. And this is something that I typically test. Do you understand that you need the absolute value here or not? So, yay. All right. I hope that helps out. Hope you bring you up to speed. Question?
Would writing 2x in the absolute value be wrong?
It's not wrong, but I'd rather not see the 2 in the absolute value because the absolute value of 2 is 2. You can just kind of take it out of the absolute value. So this one, it kind of leaves me like, I don't know what to do with that. So at that point, when I'm grading your exams, you better hope my favorite football team won over the weekend. So then maybe I'll let that one slide. But if you don't want to put your hands in the face of the football gods, then yeah, put the 2 outside. Yeah, thank you. One last one kind of like that you're going to see in the homework. X to the 2/5, y to the 3/10 raised to the 20th. What happens when I remove the parentheses? What does this exponent on the outside do to the exponents on the inside? Add, subtract, multiply, or divide?
Oh.
Multiplies. So it's going to multiply here and here. So you're going to get x to the 2/5 times 20, and then y to the 3/10 again times 20. Now notice I'm writing the 20 next to the numerator here. If it helps, maybe you can think of this as having a denominator of 1. I would suggest that you do the cancellation. The problems you're going to see in the homework are going to have some cancellation that you can do there. That's going to cancel. You'll get a 4. 4 times 2 is 8. So x to the 8. That cancels twice. X to the 8, y to the 6. So, yay. All right. That should be a good reminder and head start on the homework. Any other questions or thoughts? All right, go get them.